In this session, I'll give a live demo on external incompressible CFD analysis of Propeller by using SimScale software. To access SimScale software, open browser or Microsoft Edge and search the web address simscale.com. Next, go to Dashboard. To create new project, click on New Project. To create new project, you need to enter the project title, describe your project and choose category. I'll name the project title as Propeller. I'll describe it as external CFD analysis and choose category as aerospace. Click on create project. The first step is to import geometry required for the analysis. To import geometry, go to Geometries, click on the plus icon, click on Import from Computer, choose your geometry file and click on Import. The geometry is imported. To view the propeller, select translucent surfaces with wireframe. Now you can view the propeller inside the domain. Hide the domain. Go to active box selection. Select the propeller geometry. In the scene tree, here in the topological entity set, click on the plus icon. I'll name this as Propeller CAD mode. Click on create new set. Right click, show all. This completes our first step in analysis, that is pre-processing step. The second step is solver execution step. To start solver execution step, go to simulations, click on the plus icon in simulation, select incompressible simulation and click on create simulation. In turbulence model and time dependency, I'll keep the same default. Turbulence model will be k omega SST and time dependency will be steady state. Save it. Next, assign material. To assign material, go to materials, click on the plus icon in materials, select air and apply. Here in the kinematic viscosity and density, I'll keep the same default values. Save it. In initial conditions, keep the same default values. Save. Next, assign boundary conditions. To assign boundary conditions, click on the plus icon in boundary conditions, select velocity inlet. In velocity inlet, you need to enter the inlet velocity and select the inlet phase. In this problem, the air is flowing along y-axis, so I'll give uy as 50 meter per second. Here, the air enters through this space and the air flows out through the domain from this space. In this problem, the air is flowing out through the negative of y-axis, so the velocity will be minus 50 meter per second. Select the inlet phase. So the inlet phase is this and save it. Next, follow the same procedure. Add pressure outlet. Enter the gauge pressure here and select the outlet phase. This is the outlet. And save it. Next, in advanced concepts, numerics, keep the same default values, save. In simulation control, keep the same default values, save it. Next, assign result controls. Add forces and movement. In forces and movements, you need to enter the CG value of your geometry. And select the assigned phase from the scene tree under topological entity set. You can see the CG of the propeller here and save it. Next, follow the same procedure. This time, add forces and movement coefficient. Enter the CG value. The lift direction is along Z. IZ will be 1 and IX and IY will be 0, 0. The drag is along negative of y-axis, so dy will be minus 1. Remaining will be 0, 0. The pitch is along x, so x will be 1. Remaining will remain 0, 0. Enter the free stream velocity that you have entered at the inlet, velocity inlet, that is 50 meter per second. Enter the reference length of your geometry, area of your geometry, and assign the phase. Select the propeller CAD mode from the topological entity set from the scene tree and save it. Now we are done with the result control. The next step is mesh. To generate mesh, click on mesh. Keep the same default values, and to generate mesh, click on generate. The mesh generation step is completed. Mesh is generated over the domain and the geometry, propeller geometry. You can see the mesh generated over the geometry of the propeller. After the mesh is generated, the next step is to generate simulation. To run simulation, go to simulation runs. Click on the plus icon in simulation runs. To start the simulation, click on start button. The simulation step is completed. With this, the solver execution step complete, and the last step in simulation is post-processing step. In this step, the results are analyzed, are got after simulation. To analyze the results, go to force plots, click on forces and movement. Here you can view the values of lift and drag forces. Pressure force X is the drag force and pressure force Y is the lift force. Apart from those two, disable the other options. Pressure force X or the drag force value is minus 0.000075 Newton, and the pressure force Y is minus 2.566 Newton. To view the values of lift coefficient and drag coefficient, go to force coefficient plot, click on force and movement coefficient. Drag coefficient value is 0.0004477 and the lift coefficient value is minus 0.00000746. In this way, you can analyze the values of lift force, drag force, lift coefficient and drag coefficient. To analyze the velocity magnitude counter plot and pressure counter plot, click on run, go to post process results. In parts color, select pressure. Select surfaces with wireframe. Hide the domain. This is the pressure counter plot of the propeller. To view the velocity magnitude counter plot, add cutting plane. Select translucent surfaces with wireframe. Adjust the position of your cutting plane. Hide the domain. This is the velocity magnitude counter plot of the propeller. You can also analyze the streamlines flowing over the surface of the propeller. For that, add particle trace. Disable cutting plane. Click on the space. I'll increase the horizontal and vertical sweeps to 50. Hide the domain. In parts color, select solid color. You can view the streamlines flowing through the surface of the propeller. You can also animate the streamlines. For animation, add animation, select particle trace, increase the steps and animation speed, and play. This completes the analysis of Propeller. With this, I will end up this session here. Thank you.